you for this online CTET training program. And today our topic is Nature and Scope of Science. It is from paper 2 and Science Pedagogy. So let us move forward in this topic. So before going forward, let us see what all we can cover, or what all we are going to cover in this session. So we have all the PYQ driven classes. The PYQs will be discussed first regarding the topic that we are going to discuss, and then we'll have a content to be discussed based on the PYQ, right? So it's actually PYQs, then PYQs based discussion, then we'll have quick revision at the end. I hope all of you are following. So as I said, in this topic, Nature and Scope of Science, we'll be discussing about what is science, whether science is a product or process, or is it both. Then we'll also talk about the characteristics, that is traits of science. Then we'll be moving towards the components of science, that is a law, theory, facts, and all those. Then we'll also touch upon applying NCF 2005, how it was, how it will be, how the questions related to NCF 2005 will be appearing inside the exam. Then we'll see about how children will have misconceptions, how misconceptions will be created among the child, and how they can be rectified, you being teachers, right? So let us quickly go forward. So in this, so you can see the right side of the slide, we have nature of science. Let us quickly analyze the pattern of the questions from this topic, especially from this topic, that is nature and scope of science. So you can see these are the topics on the right side. There are major 6 topics from which the questions are being asked. Like if you see nature of science 2019, 22, 25, I am saying these years, that doesn't mean in other years the questions were not asked. This means that in these years the questions were more from this topic, right? So that is how you have to understand. When we go to the next is method, that is components of science, law versus theory, 2015 to 22, and you can see on the board just like that. So NCF 2005, 2014, in the year 2014, 18 and 15, and criteria and curriculum validity 14, 16, 19, 24, 4 years majorly focused. Then scientific approach and inquiry 2012 and 18, then children prior conceptions 2022, and it is actually rising. From 2022 onwards, the major focus is being given to children's prior conceptions, right? So this is what the basic idea and the understanding you should have about the type of questions and the major focus where the CTET is focusing in this current topic. Yes, we have already discussed the nature and scope of has very high priority, and the science approach also very high, and rest others are having medium level of priority while asking questions in this topic. Scientific approach, NCF 2005, law, theory and components of other knowledge, and children's prior conceptions. I hope you are clear with this, clear about the topics on which the major focus is emphasized in CTET with respect to this topic. Yes, so high yielding concepts. So before we go for a CTET exam, so we need to have we must know all these things that we are going to discuss now. So science is dynamic and tentative. So these are the high yielding concepts that we discussed already, and science is a dynamic and tentative process. Law describes what, theory explains why, true to the child is equal to the child's environment. Don't worry, we are going to discuss all these things in the later stages. I am just quickly revising you what I am going to discuss. Then process validity is equal to doing activities. Misconceptions, resist change. So this is where the major focus was in this topic. And quickly also see the traps that you will fall into while answering these kind of questions and questions related to this topic. So the incorrect statements, a trap bank that CTET wants you to do is science is static in nature. Okay, it's a false. Then I'm talking about all the traps that you might fall into. Scientific laws are fixed and they are absolute. False. Then science is value neutral. That is false. Then they say science is not influenced by any value system. it is neutral to the values. No, it is not. Okay, a theory becomes law once proven. Okay, false. Then children's prior ideas are easily changed. That is also false. Then reading about an experiment is equal to doing science. Okay, these are the false. So these are the like few areas where we do a lot of mistakes. Okay, as soon as we see these statements, we naturally tend to feel they are right, and we directly go on answering these and opting these kind of statements while you answer the questions. Okay, so just you can have a glance later also. Science is static in nature, very attractive and very confident statements, like anybody feel, okay, this is what is right, this is the correct statement, this can be the correct statement. The guessing work happens a lot with respect to these statements in this topic. Scientific laws are fixed and absolute. Science is value neutral. A theory becomes law once proven. Children prior ideas are easily changed. Then reading about an experiment is equal to doing science. So don't fall into these traps. Remember these statements. These are highly attractive to you. You might just directly go and opt these kind of statements when they are there in the options. Don't do that. Think. Okay. Now we'll discuss about we'll discuss the content behind these statements, and we'll try to know what is right, what is wrong, and how you should be careful while answering the questions, right? So what science actually means? Okay, what science actually means? Is it a product or a process? So with respect to this, they might ask you definitely, and they have asked in previous years also, about is science a product or a process or both? Is science a product or a process? Yes, let us say. So science as a product, it is both. Science is a product and as well as science is a process too. So when we see science as a product, what does it have? It has facts. Product in the sense the knowledge. Science has no knowledge base. The knowledge base has what does it have? It has facts, it has laws and theories. So what we know is the knowledge that comes under the product. So whatever the knowledge base and whatever the knowledge base of the science consists of, this becomes the product. So this is that is why we call it science as product. Then what is process? How science can be a process? How science can be a process? So we try to understand our surroundings through a means, right? The means is a process. So how there are methods, there are skills and attitudes required to understand and construct knowledge. So, and it is used to build and refine knowledge. So we have various methods through which we construct our own knowledge. We understand things. We need different skills to understand a knowledge, to perform something. And we should have a proper attitude, scientific attitude also. So with all these specific set of skills, attitudes and methods, we will arrive at product, that is the knowledge base. We construct the knowledge, that is product, through the process, right? That is why science is considered as both a product and process, right? So this is what it is. And below, just for your understanding, it's not much important what the different thinkers, what they have said about science. It's not majorly focused in the CTET examination, but let me tell you just for an idea to understand what science is. Okay, science, the Skinner says teach scientific attitude over rote authority. So he says a more emphasis should be kept on scientific attitude than just rote memorization. Then Pankar says organize and connect facts. Isolated facts are not equal to science. So what are the facts? Isolated facts, they are not completely equal to science. Science has made the other things also, other components also. Apart from facts, we do have theories, we have laws, all that. Okay. Then Einstein says science is universal and objective. So wherever you go, science is same. Okay, that is what the meaning of universal. It is objective. Okay, it is very accurate and universal, right? So let us move forward to PYQs that were asked. Okay, the previous year questions that were given, that were asked in the previous years. So okay, So let us go forward, and with respect to previous year questions, so how we'll be moving forward is there will we'll have a question and options, and there is a right answer, and also we'll be discussing about, you can see everything on the screen. Okay, so we have an explanation, we have a reasoning why a specific option is right and why others are not right. Okay, then a quick memory hook, what we can like how you can remember things quickly. Okay, so the first question is, which of the following, okay, this question was asked in 2019 July. Okay, so which of the following is not true about the nature of science? So the first question is about nature of science. When we went through the analysis of this topic, also the major focus was on the first concept, that is nature of science. So the question related to nature of science, which of the following is not true about the nature of science? So the options are: science is always tentative. Okay, science promotes skepticism, science is a process of constructing knowledge, and science is static in nature. So after this, after discussing the right answer, we'll also discuss about the concept. Okay, so that we understand the concept better, because concept is very much necessary to answer any kind of question that is related to the concept. So mere discussion may not help us. So we do have a plan. Okay, we do have a plan that once the question is discussed from the previous year, we'll also touch upon the content. Okay, that is based on the question, right? So the first four, so you can see the right answer is option 4. Science is static in nature, whereas it is not the characteristic of science. The question, you should give an appropriate time to think and understand the question first. Which of the following is not true about the nature of science? Okay, it's not true. The first 3 are right. Science is tentative in nature. It promotes skepticism, and it is process of constructing knowledge, whereas it is not static. Okay, we understand that how. And here the quick memory hook that you need to remember is, if an option says science is static or fixed or final, definitely it is wrong. So when there is a question related to nature of science, if any option that says science is static or fixed or final, blindly you can say that is wrong. Okay, so and this question was also asked in 2016. Okay, so the incorrect option was science is value neutral and laws are fixed. The same question was asked there. The option was science is value neutral and laws are fixed. Okay, that is not the characteristic of science. Okay, so don't fall to these kind of statements. Okay, they look very catchy and attractive, and you naturally feel these kind of statements are right, and you try opting those statements. So nature of science, as we discussed, we have seen, okay, nature, tentative, skepticism, constructing knowledge and all regarding nature of science. So we'll discuss some concept, okay, the concept related to the question that we discuss now. Okay, nature of science, there are 4 traits. Traits are nothing but characteristics. Okay, don't forget traits. I mean here is characteristics. So characteristics of science. So science is logic, science is dynamic, science needs evidence, and it is a social enterprise. So why, and so let us understand these characteristics in detail. So why science is, science is logical and it is imaginative. So ideas begin by imagination. Anything that we see, anything that we think starts from a common imagination. Okay, then it must be tested by rigorous logic, because science need logic. We cannot make general statements and general propositions just like that. Everything needs science require a logic. There should be a proper logic. There should be a proper reason for everything that we say in science, and science will have all that. Okay, and science is dynamic and tentative. Okay, dynamic means it keeps changing. It keeps changing as our knowledge base keeps progressing and evolving. Like for example, we can see we have different laws. Like for example, in biology, theory of evolution, right? The theory of evolutions are, they gradually changed over a period of time, and different scientists gave different theories, and every time the previous theories were disproved, and again the new theories were given. So the knowledge base of the science is changing progressively, right? So that is why it is dynamic and tentative. It keeps changing. The more we understand, the more we go deep, it keeps changing. That way it is called as dynamic and tentative. Okay, then it is evidence and not bias. So it requires evidence. A mere statements or description or just a paragraph or anything needs evidence in science. Without evidence, science doesn't believe anything that is without evidence. Okay, so accepts ideas only if they are empirical. Empirical means which are experimented and understood, reproducible. Okay, then evidence, control, peer review, and skepticism, removal bias. So skepticism is also one of the important characteristic in science and being scientifically right, because whatever we listen or whatever we hear, whatever we see, we should be skeptical. Skepticism is being doubtful, okay, positively doubtful about something to understand things better. Okay, as soon as I say that for example, let us take an example from biology, that mammals are the organisms which has mammary glands. They feed their young ones and they give birth to their young ones. This is what the statement I tell you. So just with the statement, it cannot be finalized, or it cannot be understood, or it cannot be taken just like that. So it needs evidence. There shouldn't be any bias from any side, right? Then social enterprise, which means science is always influenced or driven by societal needs. Like we have a lot of societal needs. Like for example, we have clothing, we need transport, we need food, nutrition, and all that. So whatever the science that we talk about in the science knowledge base that we are adding to is driven by societal needs. Okay, so it can be boon, it can be bane. In different perspectives, it is boon, and it also bane sometimes in different perspectives and different contexts. So tentative nature. So the question is from 2022, January 2022. So which classroom episode best illustrates the tentative nature of science? The tentative nature. Tentative means dynamic and tentative. That's what you should remember. Students should, the options are, I'll repeat the question once again. Which classroom episode? Classroom episode means classroom scenario. Okay. Best illustrates the tentative nature of science. Students share daily life experiences with materials, discussing how atomic models were revised over time. We already discussed how different theories get disproved and again new theories will be given. Right, drawing a diagram of the structure and asking open-ended questions about matter. So we can see the tentativeness. Tentative means which is not fixed, which is not final. It keeps changing. It keeps changing. Okay, tentative timetable, tentative schedule. What do we mean by that? We mean that is not final, that is not fixed. It may change. It can change. That is what the meaning. So that is so with respect to the tentative and dynamic characteristic in the nature, the question is based on that. So discussing how atomic models were revised over time. Over time it was changing, the atomic models, how they were discussed. So first it was Thomson who gave, then Rutherford, then Bohr, then quantum. So different people gave improvised on the concept, improvised on the theories, and gave us the best knowledge. So here models being, if you can see the memory hook, models being overturned over time. Okay, the tentative nature of science is made visible, right? So this is one. And testing hypothesis. This question is from 2022 January. Which is best suited for testing a hypothesis in science? So what is best for testing a hypothesis? Is it observation, or is it experimentation? Is it group discussion or problem solving? So the right answer is, you can see here, that is experimentation. Why experimentation? Here hypothesis, the meaning of hypothesis in assumption, a scientific assumption. Okay, so how do you test your assumptions? You test your assumptions by experimenting, not by observations. From observations, you will understand something. You get a doubt. Okay, you will form a hypothesis. That means you will form an assumption. So to understand whether it is right or not, you go for an experimentation, right? So observation is the starting process of an inquiry. Inquiry means investigation. Okay, investigation. So experimentation tests the hypothesis. So it has two different roles. Observation is not experimentation. They have two different roles. Okay, then with respect to hypothesis, then we'll move forward. The scientific method is a cycle, not line. Okay, so we can see the cyclic process of scientific method. How the scientific method happens: first the observation, then hypothesis formation, then experimentation, then analyze the data, then conclude. Okay, so in observation we just generally observe things, observe any phenomena or a problem. Okay, and we should be unbiased. We shouldn't bring our own prior experiences while observing something objectively. Okay, then we hypothesize something, a testable falsifiable statement, not a random guess. We come to a conclusion. For example, we see every day, like you might have seen lot of small organisms inside the water. There are a lot of organisms. Something that has tail with a a little bigger head, but there is a tail. Okay, every one of us might think in the starting by observing that is a fish, but that can be something else also. That like even frogs in their early stages, tadpole stage, they look they might look like a fish. Okay, so frogs when they are in early stages, they look like fishes. So we tend to think they are fishes only, but they will be frogs. Then experimentation. How do we understand that? Through experiment, control tests. We have to observe its life cycle, understand its life cycle completely. If this is the stage, okay, this is looking like a fish. Next, what is its next stage? So only when we understand the full complete cycle of a frog, life cycle of a frog, we understand whether the tadpole is a fish or a frog. Okay, then analyze data. So while experimenting, we analyze the data, we collect the data and we analyze it to understand the right and wrongness. Then we'll conclude. Okay, we accept, okay, this is tadpole, this is frog, early stage of frog, this is fish, no, this is not frog, this is not fish. So something like that, we'll come to conclusions. And whatever, if there is a requirement, if it is false, then we try to do experimentation again so that we modify what we understood. Okay, so we'll move forward. So the next question is CTET September 2015. Okay, it is about law versus theory. So the question is, which statement is true about laws and theories in science? Which statement is true about laws and theories in science? So the options you can see, theories occur in biology only, laws in physics only. They are same. The second option, they are same. Laws are just briefer theories. Third one is, laws describe observable relationships, theories explain phenomena. Theories become laws when validated. Okay, the right answer is given there itself. Laws describe observable relationships, whereas theories explain the phenomena. That means laws just state what it is. Law is equal to what. What is it? Theory means why and how. Okay, that you should remember. The memory hook is given. Law says what it is. What is the phenomena about? Okay, then theory says why and how it is happening. So the right answer is 3, and precisely laws describe what happens. Okay, then theories explain why both are valid and different, than where there are different tools, right? So let us understand a law and theory. So apart from law theory, we have facts also. So a fact is observable and verifiable truth. For example, iron sinks in water, and iron sinks in the water. Other examples can be tadpole is early stage. Tadpole is one of the stage of a frog life cycle. Okay, then ice melts at particular temperature. All these or facts. Okay, they are observable and they are also verifiable. Then data recording observations and hypothesis is testable and falsifiable guess. We already discussed that. So more sunlight, taller plants. So when we talk about a hypothesis, it's an assumption that is being made. So we might assume when there is a more sunlight, the plants will be taller. What if there is no sunlight? Okay, what if there is no sunlight? So these are the questions that arise, okay, and we go for experimenting and understanding whether the assumption is right or wrong, whether the hypothesis is right or not. Okay, so law describes what, yeah, I already said you. Then theory is explains why. So the example of law, the example of one of the law also we can understand with respect to a rule. Okay, it's kind of a rule. So example, only a 10% of energy is passed from one topic level to the next in a food chain, and in biology we study about food chains. So each food chain has its own energy level, and from one energy level to other energy level, only 10% of the energy is passed. Okay, that is what is the rule. Then theory in this perspective, for the same example, a theory can be why only 10%. What are the different tropic levels? What, how it is happening can be a theory, right? So, and we have other examples. Generally that can be the theory behind it. But we do have specific theories in science. With respect to biology, also we have theory of evolution, theory of inheritance. A lot of theories are there which generally talk about why and how of a concept. So misconceptions, CTET test. The theory becomes a law once proven. We also discussed in the first slide how you'll be trapped with the most catchy statements that CTET tries to give you. Okay, so theory becomes law once proven. So many of us may think that the theory, when a law is proved, when a law is proved, it becomes theory. Okay, it is not like that. It is entirely false. So laws and theories are qualitatively different. They are they both are different and they have different functions. Okay. Yeah, true to the child. This is from September 2014. Good science education is true to the child implies the science we teach should. Okay, the good science education is true to the child. What does this mean? A good science education is true to the child implies the science we teach should. How a science should be, when it has to be like good, true to the child. When a science can be true to the child, when it is related to the environment of the child. First option. Second option, convey significant aspects of science content. Then third, be understandable to the child. Then engage the child in process skills. So 3 and 4 also right. Okay, conceptually they are right, but they are not relevant to the question that is asked. Okay, so the second one is convey significant aspects of the science content. That is not the focus in the topic. It's about the nature of the science and science education. So it should be when the term you see true to the child, as soon as you hear the word true to the child, it is related to the environment of the child. Always remember, if you see anywhere true to the child means it is environment of the child. We also discuss about other things, like for example here you can see, so it is from NCF 2005, the National Curriculum Framework 2005. It gives the guidelines about how science should be and how science education should be. Okay, good science education is true to 3 different things, that is 1, child, then life, then science itself. Okay, the science should be true to child, true to life, true to science. What does it mean by true to child? True to child means it is cognitive, it is appropriate to the cognitive level of the child, and also it is relevant to the environment of the child. Okay, true to the child means it is relevant to the child's age and also child's environment. It is related to immediate environment of the child. Then true to life, what does this mean? Okay, science should be true to the life. That means it should meaningfully connect. It should be meaningfully connected to the everyday life experiences of the child. Okay, that's how we engage. That's how science engages a child. That's how science should engage the child. Okay, engage child in real world. Then true to science. True to science means accurate and appropriate content. So it accurately reflects the nature and process of science, not distorted from fact memorization. It's not just factual memorization. It also has theories and laws and understanding concepts, understanding phenomenon, which includes facts, but not only because of facts. So true to the child means it is environment. Okay. True to the life means it is daily life experiences. True to the science means it is content and the process. So this is how you should remember when questions related to NCF 2005 and true to the child, true to the life, and true to the science comes. So true to the child means environment and cognitive level. Life means it is real life experiences. Science means it is content and process. So the question is, this question is based on true to life. Okay. CTET December 2018. Good science education is true to life. Previously it was true to child. Okay. Now the question is true to life. Good science education is true to life means the science we teach should be true to the nature of content and science. See, nature of content and science is given in first option. Match child's developmental stage is second option. Engage in child's meaningfully in daily life experiences. Stay confined to the prescribed textbook. This is not at all relevant. Completely a different thing and wrong also. So first one, if you see, first one is content and science means it is related to true to science. Second one is about developmental stage. If you can see here, cognitive level and environment, that is related to So the third one is meaningfully with the meaning. It is meaningful to daily life experiences, true to life. Okay. So don't forget this. These three you have to remember carefully. Process validity. So there are different validities for a curriculum. Okay. So we'll discuss. The question is about process validity in science. That is CTET September 2016. Okay, the criterion of process validity of a science curriculum. Science curriculum requires that. Okay, the question is again, the criterion of process validity of a science curriculum requires that science is presented as value free and free of society. Science is taught as a specialized discipline. Okay, learners be familiarized with natural process. Then the fourth one is learners engage in process that generate knowledge. Okay, the fourth option is right with respect to the process validity. The process validity talks about learners engage in the process that generate. You can see here itself the word process itself you can catch directly to the process. So it's about how the learners process the information, how they learn, what they do in the process, so that when while understanding something. Okay, that talks about process. So process validity. So we'll understand that. Don't get confused. So there are 6 criteria of curriculum validity. The science curriculum will be there. So what are the different how a science curriculum should be and what are its validities? So one is content validity. What do you mean by content validity? The curriculum of science should be age appropriate. Okay, it should be very specific and related to the age group, that age group of the students. Okay, so it should match with the developmental stage. Piaget learning, theory you might have already known. So it should be age appropriate. Then content validity, it should be specifically accurate. Current means it is updated. Okay, it cannot be, old, knowledge or law or theory that you study. It is updated one. Okay, then only it is content validity is met. Then myth free. There are no myths, no misconceptions and all. Okay, in content validity. So science curriculum should be free of free from myths. It should be updated, then accurate. Then process. So what process a science curriculum should emphasize? So it is by doing. It should the major emphasis on by doing, but not just reading. Memorization and all. So doing means what all will be there. What all the skills that we perform are emphasized on: observe, classify, hypothesis, experiment. So these are the basic skills that we do exhibit while understanding something, while understanding anything, while constructing the knowledge. These are the things, and this is the process that takes place for constructing of knowledge. Then historical, what is the historical validity means? The curriculum also shows about how the concept has evolved, what is its historical background and all. Okay, example, atomic models over time, we already discussed that. Then environmental validity of a curriculum. Okay, it should be rooted in child's local surroundings and ecology. Okay, it should be easily relatable, it should be easily relating the concept, the examples, or anything, any phenomena that should be directly related to the immediate surroundings of the child. Then only that science curriculum has environmental validity too. Then ethical validity. How ethical validity? It should be able to build honesty, objectivity, and concern for life and environment. So science talks about everything, the whole living world and the non-living world also. So it should be able to develop some ethical values. It should like honesty, objectivity, very specific to the science, and concern for life and other the other environment. So these are six different validities that a science curriculum should have. So the questions are based on the validity now, the 6 curriculum validities of the science. Yeah. So first question is from 2014. Cognitive validity of a science curriculum implies it should be, cognitive means the thought process. So let us go to the options. First one is scientifically accurate in content, taught via correct pedagogic process. Okay, keep that in mind. Then appropriate to the child's age and level. Then fourth one is concerned with environmental and ethics. So as we discussed earlier, so if it is content, specifically accurate to the content is very different from cognitive validity. Okay, cognitive means thought process, and thought process of the child, thought process in that particular age. So the second answer is right, appropriate to the child's age and level. So our cognition will change over a period of time. So science curriculum should be really, appropriate to the level, age level of the child. Then curriculum validity, 2019 question, let us see. Students do an activity and an experiment. Which validity criterion is satisfied? Okay, students do an activity and an experiment. Which validity criteria is satisfied? What is it? They are doing an activity, performing something, performing an activity. So it is a process. With the name itself, if we go with the meaning of the the statement or a word that is given, we'll understand half of it. So cognitive validity, no. Content validity, no. Historical validity, no. It is talking about the activity and an experiment which is related to the process of it. So it is process validity. How science is taught across different stages and how science should be taught in different stages, according to NCF 2005 recommendations. So science we do study in all the stages. Okay, in all the stages. So how science should be from in primary level, how science should be in upper primary level, how science should be, or it is in secondary level, because as we move from primary to secondary and senior secondary, the cognition also changes. So based on our cognition and understanding level, how science should be. So how science is being planned, okay, according to the NCF 2005. So science is not separate, okay, it is integrated with EVS. It is integrated in EVS along with social science and languages itself. So there is an EVS subject which, like when we talk about paper 1 of CTET, you will learn, like there is a subject called EVS. All of you will be knowing it. So EVS has the component, all the components, from social studies, then languages and science too. So it is integrated with other subjects and dealt in primary level, that is from 1 to 5. In upper primary level, that is from 6 to 8. So science becomes independent. It becomes an independent subject, coming out from social studies and languages. So it becomes independent. It becomes experiential and hands-on activity and hands-on everyday phenomena, the key transition stage. So when you come to upper primary, it becomes very independent, and it is more of experiential in nature, more of doing things and learning. Whereas it is these are the characteristics of how science is learned and taught in upper primary level, but it is independent it is an independent subject in upper primary level, whereas when you come to secondary, it is even more depth and divides into three different subjects again: physics, chemistry, biology, the composite science. So diving deeper and understanding principles, models, quantitative lab work and all, everything comes, and this is how science changes from one level to another level. So primary level, upper primary level, and secondary level. So 1 to 5 it is integrated. So when you see any question that talks about science curriculum in 1 to 5, remember integration. Then 6 to 8 it is separate experiential. Okay, it is separate from other subjects, it is independent as we discussed, and it is experiential in nature. So 9 to 10 it is again divided into three different subjects: physics, chemistry, biology. Okay, and this progression is linked directly. Okay, yeah. So scientific approach, so regarding scientific approach, scientific approach, which is regarding scientific approach 2018. So which is the most appropriate for a scientific approach in teaching. So we'll discuss one final question, and we'll go to quick revision once so that you'll understand better, because I have already discussed 4-5 questions, and we also discuss the content. So majorly to how we should be prepared and how we should be careful while answering questions from this topic, that we'll discuss soon after this slide. Okay, what is most appropriate for scientific approach in science? So the first option is show use of technology to teach concepts, give projects to students, ask students to perform activities and concepts. So as we discussed, it should be more of experiential in nature. So performing activities and concepts is the right option. So we'll directly see how the quick memory hooks that you should have before going to CTET with respect to this. The incorrect statements. So these are the incorrect statements which everybody naturally feel they are right, and they tend to answer wrong. So be careful. Science is static and final. Be careful with these kind of statements. Okay, scientific laws are fixed and absolute. Science is value neutral. A theory becomes law once proven. Reading about an experiment is equal to doing science. Then prior ideas are easily changed. So these are the wrong concepts which anybody naturally feels right, and they are the traps that CTET keep for you. So be very careful with these kind of statements. Then scope of science. So we have natural science, physical science, life science, and social science. You already know that. And the modern curriculum should have the developments through science, the space science, biotechnology and all. Then quick fire check. So we'll quickly revise what and all we did in today's session. So Latin scientia means knowledge. Skinner saw science, this is not necessary. Then iron sinks in water is a scientific. Is it a law, theory, or a fact? It is a fact. A primary stage, the science is integrative in nature. Teaching atomic theory, evolution satisfies historical validity. Using local plants and rivers satisfies the environment validity, because it is related to the local, it is relating to the local environment. So the 6 lines, please remember these lines before you go to the exam. Very important. Science is dynamic and tentative, never static and never absolute. Okay, law is what happened. Law talks about what the phenomena is, and theory talks about why and how something is. Okay, law is what, theory is why. Remember these things, the tricks. True to the child means related to environment. True to the life means it is meaningful, and true to the science means it is accurate. So process validity is talking about doing activities, emphasizing more on activities. Cognitive is age appropriate. Okay, so these stages just now we discussed. And misconceptions resist change. So elicit conflict, then change. So this is regarding misconceptions. Not much focused in CTET papers, but there are questions regarding misconceptions also. But yes, with respect to this concept, so be careful with these kind of statements, and how you should answer we discussed right now. And I hope you are clear with it, and we'll end the session now. Thank you so much.